Okay, write an expression involving an integral. So we've got to have an expression using an integral that gives the position s of t. Stop, there's a period. Okay, that's easy because I know that in this case my amount is the position. My rate at which position changes, that's velocity. So the fundamental theorem says if I integrate the rate, gives the position at any time here. It's not saying a specific time. So I want to start at time 0 and just go to any time. If I integrate the rate, v, but I can't put a t, I must use a different variable, so I'll use z. This integral computes how different the two positions are. So it will compute the difference between the position at any time in the future compared to the position at time 0. I chose time 0 because I already know that at time 0 the position is 10. So now I have the equation I need. I just rearrange a little bit. My equation is s of t, the position at any time, can be found by saying, well, you start at a position of 10. If you integrate from time 0 to whatever time you choose, the integral of velocity will compute how different the position is at time whatever compared to what the position was at time 0. Knowing that change in position, combining that with what the position was at time 0, you find the position at whatever time you choose. So that's the integral expression that will find the position at any time. Let's check the scoring on that. So sure enough, for doing that, I get 1 point. So I keep reading. Use this expression, use this, to find the position at time 5. No more difficult than simply plugging in 5 in place of t. They do expect you to write integrals when you use them, so write out the integral, run that through your calculator, you get a second point. So here I am. The integral itself tells me how different the position is at time 0 compared to time 5. So the idea is the particle's moving along a line right here. The particle's moving along this line. This location in the center is called the origin. Here's where the particle is at time 0. And however the particle moves, the integral from 0 to 5 of the velocity tells us that this is how different the position is at 5 compared to the position at 0. So that's what this number represents, how different the two positions are. Therefore, we're able to compute that this must be the position at time equal 5. This is where the particle is located. 2 total points for part B.